Hi, I'm Steve Goodhue, PI for the CobBauge project, which is a European funded project to take an ancient cob material and optimize it for the 21st century. And we're working with a number of different partners here in the UK and also in France. And we're looking to take that material and prove it within a prototype on the Plymouth campus. And Kevin Owen is going to give you an idea about the materials that make up that particular optimized material.
Hi, my name's Kevin Owen. I'm Senior Technician with the CobBauge project. And here we can see how we've constructed our composite wall. We've used what would be traditional cob for the structural side. And on the other side, which is formed as we build the wall, we've a mixture of hemp shiv, which is this material, and we put it into a very clay-rich slip, and we make this material, which, when it's compressed and dried, forms the thermal part of the wall. Now, the thermal part of the wall and the structural part stick together naturally because of the clay content, which makes a composite material for the wall itself.
Hello there, I'm Jim Carfrey, one of the researchers on the CobBauge project, and these are the two full-scale walls that we have built to prove our concept. And the way that we're going to prove it is by monitoring these walls. We're monitoring their movement, we're monitoring the drying times, but most importantly, we are going to build a room by putting a wall plate on the top of each wall, joists across, and then we apply the typical dead loads of a building to demonstrate the efficacy of the material.
One of the major aspects of knowledge that these walls are going to provide us with is the monitored information on moisture contents and also the movement within the wall itself, and finally, as Jim's talked about, the ability to crush them. Sensors are embedded in the wall down here, and there are two across the middle of this particular wall, and there are also another number of sensors further up in this section, and these are counterbalanced with a calibrated element which is further down over here, which is a soil view, which is a little bit like a tube which has got 5 sensors running across it. All of these are then going to be presented at Terra 2022 in a form of a paper that looks at this moisture content versus movement.
This is the door side of the wall that we've constructed, and you'll see there this has got a timber lintel in it. It's a little bit low because we're treating the ground as the plinth, and what we've got here is a piece of 18mm ply that goes all the way across both walls with softwood timber in between to give it extra strength, and this laps out on either side to give it strength on its shoulders. This is the other side of the wall, which is the external side. And you can see there that the lintel is still visible. This side you would render on the outside. And we've also included some timber framing, which actually extends into the structural side for extra strength. And it's the kind of thing that you would attach, say, drain pipes to, or guttering, or articles that you wanted to attach to the wall. So this is to test how this would work. And at the moment, it's very, very stable. It's not shifted at all. And I'm sure you could put quite a heavy weight on there.
I hope you enjoyed your trip through the knowledge-based research we're doing at the University of Plymouth and with the CobBauge project. The future is going to look like these buildings being built over 10 years after the project's finished. And if you wish to know any more, I'd like you to have a look at our website, which has got all the technical information you need.